Pre-statistics, using the quadratic formula to solve quadratic equations, Part 5. Lesson objective. Example 12. The number of children with autism who are enrolled in special education classes has increased greatly in recent years. See Table 7. Possibly due to redefined diagnoses and public awareness. So we have data from the years 1995 to 2003, and from this data we see that the number in the thousands is increasing each year. Let n be the number in thousands of special education students with autism at t years since 1995. A linear model of the situation is n equals L of t equals 12t plus 14. A quadratic model of the situation is n equals q of t equals t squared plus 4t plus 22. A. Use a graphing calculator to draw the graphs of both models and, in the same viewing window, a scatter plot of the data. Which model describes the situation better? To put the data in the calculator, I'll go to Stat, then number 1 for Edit, or hit Enter. I have the number of years since 1995 in List 1, and in List 2 I have the dependent variable, the number of students in special education with autism. To see the scatter plot, I go second, y equals, which is stat plot. Currently the stat plot's turned off. I hit Enter. Enter again to turn it on, and we can see the scatter plot is on. List 1 is our X list, list 2 is our Y list, and then I hit zoom and number 9 for zoom stat. Now this could be modeled by a linear or quadratic. We're going to try both and see which one, according to the scatter plot, is doing a better job. So I'll go to the y equals. I first put the linear function in. L of t equals 12t plus 14. Hit graph. And we can see that the linear model is doing a pretty good job of modeling that data. Let's look at the quadratic. So we go back to the y equals x squared plus 4t plus 22. Hit graph. It appears, according to the scatter plot, that the quadratic is doing a better job of modeling this data. Part B. Determine which model predicts the larger number of special education students with autism for the years 2000 to 2016. To answer this problem, we're going to use our table command. Second graph. We want the years for 2000 to 2016. So 2000 would be t would be equal to 5. L1 is the linear model. It's estimating 74,000. And Y2 is the quadratic. It's estimating 67,000. So for 2000 and also for 2001, when t is 6, the linear model is larger. After 2006, Y2 is larger than Y1. So to answer the question, we would say for the year 2000 and 2001, the linear model is estimating a larger number. After that, the quadratic up to 2016 is estimating the larger number. Part C. Predict the number of special education students with autism in 2012. 2012, t is 17 years beyond 1995. So to do this algebraically, we start with our quadratic model, and everywhere we see a t, we substitute 17. and we get 289 plus 68 plus 22, which equals 379. To interpret this number, we would say, according to the quadratic model, in 2012 there were 379,000 special education students with autism. Part D, estimate when there were 43,000 special education students with autism. In this case, we are given Q of t equals 43. We substitute that into our quadratic model, and the first step to solve this algebraically, we would subtract 43 to both sides to put this in standard form. So now we have 0 equals t squared plus 4t minus 21. Using the quadratic formula, we have a is equal to 1, b is equal to 4, and c is equal to a negative 21. Substituting the values of a, b, and c in the quadratic formula, we now have negative 4 plus or minus the square root of b squared, or 4 squared, which is 16, plus 84. And that would be 4 times 1 times a negative 21. And if I subtract a negative number, that becomes plus, divided by 2 times 1, which is 2. 16 plus 84 is 100. Now we take the square root of 100 and we get 10. So we have negative 4 plus or minus 10 divided by 2. So splitting up the plus and the minus, we have negative 4 plus 10 divided by 2, which becomes 6 divided by 2, which is 3. And negative 4 minus 10 divided by 2, which becomes negative 14 divided by 2, which is negative 7. So we would interpret this according to the quadratic model. There were 43,000 special ed students with autism in both 1988, that is when t is negative 7, and in 1998, that's when t was equal to 3. Verifying those two parts using our graphing calculator, we see that when t, or in this case x, was 17, we had 379 for y2. And if we go back, when t was 3, we have 43 for our y2. And if we go back to negative 7, and again, y2 is equal to 43. So we have verified both parts of the question. Thanks for watching.